So, for my system, I did a boiling pot of water. And from chapter 1, I chose temperature, which is an intensive property. And temperature is proportional to pressure, but since pressure in this system is held constant, that means temperature is the only thing that's changing. Temperature is transferred from the stove to the pot of water, and since the system wants to be in equilibrium, that means the energy is transferred to the surrounding air after it's transferred to the water once it's boiling. Then the more heat added, the hotter the water gets. From chapter 2, I chose the conservation of energy, which means energy is not created or destroyed. So energy is put into the system from the stove, and from the steam coming off the boiling water, that means that energy before is equal to energy of the boiling water plus the energy of the steam. And then from chapter 3, I chose phase change, which in this system, water, once it comes to a boil at 100 degrees Celsius, that means it's created from a saturated vapor, turned into a two-phase liquid vapor, and then if you let it boil long enough, it was turned into a saturated vapor. And from chapter 4, I chose a mass flow rate because mass is not created or destroyed. That means the mass of the water before is equal to the mass of the water after plus the mass of the steam. And then from chapter 5, I chose the second law of thermodynamics, which means energy cannot be transferred from the pot to the stove, since the pot is the cold body and the stove is the hot body. And since the release of the vapor to the surroundings, the non-perfect efficient means that this is an irreversible process. And then entropy is produced because of a constant heat transfer, and energy is transferred through or by conduction.